Alright, so what I'm hoping today is for us to really get to have a big overview of how we can read and use graphs of different types. Today we're going to focus on line graphs, which I bet most of you have seen, in bar graphs, which I suspect also are kind of things we're familiar with. And as we start, a couple sort of main rule of thumbs. Graphs have titles. Titles tell us mostly what's happening. When you're making graphs, remember to put a title on. Right? You want to communicate some information. The axis, like the x and y axis, they also have titles. They need to be labeled. Usually what we're looking for on the axis is actually what it is and the units. Distance in kilometers, or weight in kilograms, or amount of bananas in number of bananas, or whatever, right? Whatever you're measuring with whatever the units are. There's going to be generally two parts of a graph, at least a two-dimensional graph. It'll be whatever is the manipulated variable. Time is the most common, but there'd be other things too. And then the responding variable or the dependent variable. You'll hear independent or manipulated as the x-axis. You'll hear dependent or responding in the y-axis, depending on whose science class you're in. Basically, x-axis is the thing you change. Y-axis is whatever gets affected by that. Okay. Let's start with a broken line graph. If I can get this thing working. Okay, so let's look at this thrilling graph on hippo populations. A broken line graph uses points connected by a line to display data. One of the things that I'll mention to you initially, in general, when there's a line on a graph, it's saying the stuff in between these points matters. So, on this example of hippo population, the reason why these data points are connected is it's saying the amount of hippos over this time kind of changed from here to here, or like there was stuff happening between whenever this is in 2005 and whenever this was in 2006. You'll sometimes get asked, should you connect these points or not? Really the question is there points in between or not? So sometimes yes, sometimes no. It's not something I'm going to hammer you on. But so there's a study on the growth of hippopotamuses at Eastland School, okay, maybe not, but at somewhere, over time. So in 2005, 6, 7, 8, 9, 10. Now, initially, first thing to be able to do is just read a point. Okay, so in 2010, how many hippos were there? How do we do that? So yeah, all we do is we kind of basically find the points, we go across whoever that was. Okay, let's read this axis. So if it's this line here, and the thing is going like 24, 28, 32, 36, what's each of the smaller lines then? If it's 4 for every 2 lines, how much is it for every 1 line? 2, okay. So it's 32 plus 2, so there's 34 hippos in that. So, or we could say this point is, in 2010, there are 34 hippos. Right, that's that point. 34 hippos at Eastland School, yeah? Well, I was just so excited with this thrilling, input of math information, and instead I get F1. Maybe we should do like a test though. Every time you want to go to the bathroom, you have to like do a mad minute or something.
That's awful.
Yeah, you're right. That might be like cruel and unusual punishment. Okay, how about 2007? How many hippos in 2007? Beautiful. Yeah, exactly. It's between 24 and 28. Easy, good. Where? I got 26 for this. Okay, now what about if you're asked the other thing? Okay, so now it's being asked, okay, what year did it reach 30? So instead of saying what year instead of saying, okay, when is it 30? So we go from 30, we basically line across until we get to 30. Oh, yeah, right there. 2008. Brilliant. Okay, now we got these min and max questions. Out of this range, what's the minimum hippo population? What's the lowest one? Yeah, the first one. So that's 2005. And maybe another piece can say, if the minimum was in 2005, what was the minimum value? It was in 2005, how many hippos were that year? 12. Right, so there were 12 hippos. Good. Or we could say, in 2005, there were 12. Okay, now difference. How many more hippos were there in 2008 than in 2006? Yeah, because there was 30 minus 20. So 10. 30 minus 20, there's 10 more. 10 more. And in this case, if you were asked what's the difference, then you would want to say 10 more. In this case, it already says how many more, so 10's good enough. But good. So what I hear initially, you guys are good at reading line graphs. That's a skill most of you are got. Everyone is correct. Yeah, exactly. It sounds like really good. Really good. And I sure hope so. I sure hope so. Because you've been doing this for years. You've been doing this for years. But this is like preliminary. Can we read a line graph? Now, the things we're looking for, what does the x-axis say? What does the y-axis say? What's the units? And how do I find different points and use them? Really good. Okay. Well, I think I'll let you try it. One of my great passions in life, hot dogs. Okay, maybe not. But let's figure this out. What do we see about these hot dogs? You spend a minute, try these on your own. Try reading this simple broken line graph, see what you can do. Okay? Go. Just so can I see who's done? Who hasn't started yet? Not admitting it? Okay, so looking at this, how many hot dogs are sold Monday? 7. Nice. These ones that are right on the line are kind of nice, saying we don't have to do too much interpreting between. So on Monday, there were 10 sold. How many hot dogs were sold on Wednesday? Nice. 30. Which day was the most? Friday. Oh man, crushing this. And how many more were sold on Thursday than on Tuesday? Oh yeah, the difference. The difference is just 10. Good point. And how many more were sold on Wednesday than on Monday? 10 more. Or what's the rise from Monday to Wednesday? 10. Monday to Wednesday, not 10. And, okay, one more question here. How many hot dogs were sold this week? How many hot dogs were sold this week? The trick would be just to say 80, but no, 80 was just Friday. I want to know how many sold this week. During the week, how many were sold? How do you do that? Nice.
230.
140, 190, 230. Yeah, really, 230. Good. Okay. We'll do one more thing with this for now. I want to talk about how we notice kind of what happens over time, looking at trends, looking at increases, decreases. The first term you'll need, and warning, your final exam uses these terms. It might be worth knowing. They're actually probably kind of easy ones to remember though. Interpolate versus extrapolate. Extrapolate, interpolate. All that that's doing is, let's say on this hot dogs thing, we didn't have one of the data points. Let's say we didn't have Wednesday. So we had Monday, Tuesday, Thursday, Friday. We didn't have Wednesday. Interpolating is basically finding the point in between some others. So if you're like, okay, what's the thing in between these? How do we find, kind of based on the trend, what's happening in between these points? Extrapolating is extending it. It's saying, if you take this line, what happens over here? Right? So maybe you can extrapolate and say, if this kind of holds, what do you think might happen Saturday? That's what extrapolating is. Whereas interpolating is saying what happens in between. Or in a case like this, interpolating could be saying, you know this data, what do you think might have happened Wednesday afternoon or something like that, right? Like it's somewhere within the data, extrapolate is going beyond, going outside of the data.
This voice, can I use basketball?
All in favor?
No.
Opposed? Oh, these guys are mean. All right, Isaac, you go.
Yeah.
I feel heartbroken that you guys want him to have to sit there and have that bad of an experience in our wonderful math class, which we all share and love. Okay, so we're going to do some interpolating and some extrapolating here. Air temperatures in Lethbridge. Any of you guys ever been to Lethbridge?
Yes.
One of my friends up in Lethbridge is kind of famous for being winky. He said that when he was a little guy, they used to, on recess, open up their coats and use their coats to fly across the playground. I don't know if it's true or not. I like to think it was.
I believe it.
It's pretty windy. I ran a big race there and I had like a headache for a week from the wind. Okay, temperatures in Lethbridge in April. Here we go. Sounds like the beginning of a joke. So, on April 1st, simple one. On April 1st, what's the temperature?
16.
Right, just looking up. Oh, it's 16. Sounds nice. I wouldn't mind 16 right now. Okay, which day had an air temperature of 6? I go on 6, I look across, I see, oh, it is Feb 22. Okay, based on this data that we see, what might the temperature be on April 11th? So this is one where it's saying kind of approximately what might it be. So April 11th, somewhere in between here. So what would be a reasonable approximation for April 11th there?
11?
Yeah, I think so too. Looks like that's about the best guess. Now, in a situation like this, do we know that for sure? No, and it's actually very possible. It only has points at these dates. That very well, it could have gone more like this during that period, right? It might not have just been straight lines between there. But based on the data we have, this is the best guess we can make, okay? And what might the temperature be on April 25th? What might be a good approximation for temperature on April 25th? Yeah, I think so too, probably about 7 degrees Celsius. So both of those were interpolated. In the middle of the data, we're making a decision based on what we see in between other points. Okay, and now if we extend this data, what might the temperature be on May 6th, or 1 week from April 29th? Now, first of all, do this with the data, and then tell me why it's a terrible answer. So first do it with the data, and then think about it and tell me why it's so stupid. So let's look, okay. On May 6th, what's kind of been happening with the data over this time?
Down, up.
Yeah, and it's been going quite a bit down, a little bit up. Quite a bit down, a little bit up. So if we were making sort of like a trend line, it looks like the trend line is kind of on the whole doing that, right? So I'm guessing May 6th, I don't know,
4.
maybe something like this.
No, 3 down, 2 up.
Right, but sorry, it's not precise. So you're absolutely right based on the one I drew, but I'm just saying it's somewhere over here. So somehow it's down there, maybe 3, maybe 4, somewhere in there. So, okay, we can say somewhere, put your prediction, what you think it would be. But now think critically. What happens in April, May, June, usually in Alberta? Change, what does it get from colder to warmer or warmer to colder? It should be getting warmer, shouldn't it? And it's kind of surprising that over the month of April, temperatures would, I hope the temperature's not going down in April this year, getting colder and colder toward May. I hope that it's getting warmer from this, right? So I see the data here is telling me it's probably going down. But there is some thinking you can do. You can say, okay, the data says it's going down. But actually, I bet you at some point here, we're going to get that again, right? At some point in May, it should start getting warmer, right? So I always like thinking through it like this. The answer to this question is, Alistair's absolutely right. Probably something like 3 or somewhere in there. But I'm like, it's kind of a stupid answer based on what I know about the temperature number. Yeah?
You say Alberta?
Yeah, Lethbridge is in Alberta. It's a city in Alberta. Lethbridge is the 4th biggest city in Alberta. It's kind. You guys, this is probably not the kind of thing you care about unless you're from Red Deer or Lethbridge. No, for basically my whole life, Red Deer and Lethbridge have been within like 5,000 of each other. So like when I was a kid, Red Deer was 55,000, Lethbridge was like 52. Then Lethbridge went above maybe 60,000 people, and Red Deer was like 56. And now they're both in the like 110,000 people range. But Red Deer is currently the third biggest city in Alberta, and Lethbridge is the fourth, 1,000 smaller. But they're always having the fight. The mayor's always saying, my city's the third biggest city in Alberta, my city. So Lethbridge is the fourth biggest city in Alberta right now, said by someone from Red Deer. And based on this, what would I predict? Well, I would predict somewhere around 4 degrees Celsius and say, but I think it'll bounce up. Right? Because I think you got to think at some point in May it's going to warm up. Hopefully. In fact, seeing a trend line like that going down, it's like, that looks like it's fall, right? That doesn't look like spring. It looks like it's slowly getting colder, not warmer. I'm like, this looks to me more like air temperature in October, not in April. Oh, I'm just saying, I think it will go up. Will. Don't worry, you don't have to copy it. I'm just saying, that's what I think would happen. That's what I think would happen. I don't think it would keep going down. I think it will go up. I've lived in Alberta for long enough. Okay, and you guys get one more before I give you a different activity for the next while. So give this a try. This is property tax rates. This question, I need to clarify something that you'll find confusing. Maybe you guys are like on social media and saw some complaining recently. So Edmonton recently had a big property tax increase. What happened is basically a bunch of home assessments went up. They assessed values as higher than they'd been before. And that makes sense, actually. The property assessments were kind of low in the past. But what this is talking about is, it's talking about how much tax someone pays on their house per $1,000. So like, if your house was, say, worth $100,000, you would pay, whatever, $8 per 1,000. So you pay, in this case, if it's $100,000, you pay $800 on that amount. So this is a rate. It's saying rate per 1,000, how much they pay per 1,000. So it's a little confusing to read, but that's what's on. What's the rate per the cost of your house? So you guys start trying this, recognizing this is talking about a rate. This is actually a more confusing graph than I would ever test you on, but I think that being able to read it is a good skill. So give this a try, see if you can interpret this graph and answer these questions, okay? Go.